Assalamu alaikum, dear students. Our today's topic is about interstitial sites or voids in case of these solids. We have already discussed the three-dimensional packing of spheres in case of these crystalline solids, and this, as we saw there, that this uh, there we saw there is two possibilities are there. One type of is that is called as hexagonal closed packing, in which I told you that the third layer, it is the repetition of the first layer, that is AB type. And then another type of this packing in case of these in case of 3D crystals, there is that is cubic closed packing, or it is also called as this phase close this packing. Now in this case, in case of cubic, we see that the fourth layer, it is the this fourth layer, it is the repetition of the first layer, that is ABC type. Now as far as these interstitial sites, or we call them as also call them as voids, are concerned, now while building, as in case of 3D, this 3D packing, when we say, when the second layer is built over the first layer, we see that only half of the hollows in the first layer are filled. That means, since as you, if you don't remember, I have told you that we have got two types of hollows are available in the first layer, that is type A and type B. So only one type of hollows we can be occupied there. Either A type hollows or B type of hollows can be filled. Now as far as these interstitial sites are concerned, now in close packing of these spheres, we see that certain hollows are left vacant. Now these vacant hollows, are these voids or hollows in the crystal. They are called as they are also called as the interstitial. They are also called as interstitial sites. And we have got their two types of these interstitial sites are there, or voids are there. One type of this interstitial site or the void, that is called as tetrahedral site or the tetrahedral void, and another type that is called as the octahedral void. Now as far as these tetrahedral these voids or sites are concerned, in this case we see that a sphere in the second layer, you can see this is a sphere in the second layer. It is placed above the three layers. It is placed above the three spheres which touch each other in the first layer. Now the centers of these spheres, they lie at the apices or at the corners of a tetrahedron. So the shape of the void, now the shape of the void is not actually tetrahedral, but it is the arrangement around this void. Now since this is a tetrahedral void, you see that these are the spheres which are shown by this solid line. Now these are the spheres of the first layer, and this dotted line, it is the sphere in the second layer. So we see that that these spheres, they lie at the corners of a tetrahedron. So that is why this is called as tetrahedral void. Now this vacant space, now this the vacant now the vacant space among these four spheres, you have got first three spheres in the first layer, and the second sphere in the second layer. Now these the gap or the space among these four spheres having a tetrahedral this arrangement, that is called as tetrahedral site. You can see this is a tetrahedral site. Now you can here also see, then you have got another type of we have got another type of this void or site, that is called as octahedral site. Now this type of void is formed, it is an octahedral void. It is formed at the centers of the six spheres. You can see here. Now three spheres in the first layer and three spheres in the second layer. Now it is produced by, you can see here, it is produced by two sets of equilateral triangles which point in opposite direction. Now the void that is formed between these two equilateral triangles with the apices in opposite direction. You can see here, one this sphere, it points in this direction, and this sphere, the three spheres of this triangle, they point in this direction, so they are in opposite direction. So this type of this void is called as octahedral void, or we also call it as octahedral site. Now this is, now this, as far as this side is concerned, this is concerned. Now this void, it is surrounded by, you can see, six spheres. You have got here six spheres, which lie at the vertices of a rectangle, of a regular octahedron. So this is called as, that is why this is called as this is called as octahedral void. Now in case of these tetrahedral voids, or in case of tetrahedral, these tetrahedral sites, we see that there are two. And you can see, in case of this hexagonal close packing, or in case of cubic close packing, we see that two tetrahedral sides are there for each sphere, and there is only one, this octahedral side for one sphere. Then we have got this coordination number. Now you can see coordination number, as I have already told you, it is the number of spheres which are touching a given sphere, that is called its coordination number. Now in case of a hexagonal close packing and in cubic close arrangement, we see a sphere, that there is the sphere is the sphere in case of cubic close packing, or in case of hexagonal close packing, it is, a sphere is in direct contact with the with other six spheres in its own layer. So in its own layer, you see this is the sphere, this is in contact with the six spheres. You can see also here it is 1 2 3 4 5 6. Now, so the sphere is in contact with the six spheres in its own layer. It also touches three spheres above it and three spheres below it. So in all, the coordination number in case of this hexagonal close packing, or in case of cubic close packing, it is 12. Then we have got a radius ratio. As far as this radius ratio is concerned, we will discuss it in our next lecture. So this is for today. Thank you very much.